Latin square designs, in their simplest form, are grids that are similar to those used in Sudoku. Where Sudoku has numbers, Latin squares have letters of the Latin alphabet, giving them their name. Each of these letters must occur once in each column and each row. In statistics, Latin squares can be used for three-factor analysis of variance, or ANOVA. When using Latin squares to analyze data, the rows, columns, and individual units each represent one of three factors in an experiment's design. Given this, it makes sense that their use requires the experiment have three factors, and that each is available in the same quantity, n. Each column represents one instance of factor 1, each row an instance of factor 2, and each letter an instance of factor 3. In an engineering example, this can be used to represent data in a load before failure experiment. Here, the three factors would be the day of data collection, the machine used, and the alloy tested. Located within each box would be the data value collected from the combination of its three factors. For example, in the unit that is selected here, the value would be the load before failure of alloy B, calculated using machine 2 on day 3 of experimentation. The setup of Latin square designs is useful because it allows us to easily isolate each factor in an experiment. When using Latin square designs in ANOVAs, the sum of squares needed are that of each row, each column, and each treatment. The degree of freedom would all be n-1. This information can then be used to make the appropriate calculations needed for our ANOVA table. Other than the sources of variation being listed as rows, columns, and treatments, the ANOVA table for a Latin square design is pretty standard. Generally, this method is used to simplify the data collection process, especially if the collection of data needed to satisfy each combination of these factors would be otherwise impractical. For example, if data collection is constrained by time or budget, Latin square designs might be the way to go.